When you get onto page 9, you're going to encounter isomerism in transition metal complexes. Now, we have covered isomerism before in Introduction to Organic Chemistry. So I just want to do a very quick recap on that, so then you'll see where the isomerism in transition metals fits in, because it's a new type of isomerism that we haven't covered previously. So if you can remember that to be an isomer, so isomerism, two molecules must have the same elements and the same numbers of each atom of those elements. So for instance, you could have two molecules with the molecular formula C4H10 rearranged differently, but they will be isomers. Something that has a molecular formula of C4H8 can never be an isomer of C4H10 because they've got different numbers of hydrogens. So we're looking at molecules where they possess the same number of atoms of each type of the element. So what we've covered previously in organic chemistry is we started drawing this family tree, and this family tree gets split off into structural isomerism, and we've got another one over here which I'll cover in a moment. But structural isomerism, so same molecular formula, different structural formula, that can be further split into three, of which we've got chain isomerism, position isomerism, and functional group isomerism. So chain isomers, these are where, in organic chemistry, where you've got a different carbon chain length. For instance, you could have butane, or you could have methyl propane. So those are chain isomers. Position isomers, this is where we've got the functional group in that organic molecule, and it's on a different carbon atom. So we could have butanene, and butene. Now there is another thing that we'll cover when we get back onto organic chemistry associated with butene. And then finally, functional group isomers. This is where they possess an entirely different functional group. And at this point in time in organic chemistry, the only ones that we've met which fall as being functional group isomers are alkenes and cyclic alkanes. So we could have cyclobutane and butanene. Both of them are C4H8. Okay, right, that's the stuff that we've done previously. There is a definition for structural isomerism, which you do need to know, and I mentioned that earlier. I'm not going to put it on this. It's in your notes in the Introduction to Organic Chemistry. Now, the other type of isomerism that we haven't covered, but we will now begin to cover, is called stereoisomerism. Now, stereoisomerism, and I'll write the definition down here. This is the same structural formula, but a different three-dimensional arrangement of atoms. In space. Now, there are two types of stereoisomerism, and certain complexes display both of these. The first one is called geometric. The second one is called optical isomerism. And what I'm going to do in subsequent videos is explain what types of complexes can fit into either one of these two and how we would go about representing those isomers if you were asked to draw them out. All right, thank you.